Today we're going to be talking about proportional relationships. The first thing I'd like to discuss is that slope, constant of proportionality, and unit rate all mean the same thing. They all have the same meaning. They're referring to slope, remember, is, as we've been discussing, is the rise over the run, or the change in y in the change in x. A constant of proportionality is the m of this equation, y equals m times x, and unit rate. So we remember slope is a fraction, and unit rate is also a fraction that measures, is a measure where the denominator is 1. So miles per every hour, feet per every second, etc. So let's go ahead and check it out. If I'm looking at this graph, remember I can find the slope of this graph by finding the rise over the run. Notice if I start here at 0, 0, I also cross through this point right here, which is 1, 10. Now, what is my rise over my run? Notice that my units go up by 10. So as I rise 10, I run 1. So what is my slope? Remember, slope is written as a fraction. 10 over 1. And we can always simplify our fractions, and so slope would be written as 10. Constant of proportionality equation. Remember that I had y equals, and then it said mx. Remember that m stands for my constant of proportionality, or my slope. So we calculated our slope as 10. Okay, so I'm putting 10 here. A slope and that constant are the same thing. So 10, 10. My unit rate is a fraction over 1, 10 over 1, same as my slope. So whenever I refer to any of these three things, slope, constant of proportionality, or how proportional something is, or a unit rate, we're all talking about the same number. So here's the biggest key idea. When two quantities, x and y, are proportional, the relationship is represented by direct variation equation, and that is the same as my constant of proportionality equation, y equals m times x. And m, where m is that, how proportional it is, or my slope. And the graph is a straight line that passes through the right here, passes through right here at 0, 0, and their special name for that is origin. So key idea, whenever we're talking about something being proportional, hey, that is the same thing as calling it direct variation. So let's go ahead and begin. Let's discuss and determine whether or not each of these relationships is proportional. And if they are, remember, proportional constant is the same as slope. We're going to identify the slope. So if I go back to my definition, a direct variation would fit this equation. It's going to be a straight line, and it's going to pass through the origin. Well, this fits the straight line criteria. But do any of these points pass through the origin, which is right here? And the answer is no. So I would say not proportional. And I could also say it's not direct variation. Okay, whenever you see not proportionate or direct variation, they're talking about the same thing. All right, second graph. Does it pass through the origin? Yes, it does. So this is proportional. And that means it has direct variation, because those two things mean the same thing. And let's calculate our slope. So I have a point that goes through the origin, and I see as I go along that I also have a point right here at 1, 1, because it lines up perfectly. So I'm going to calculate the rise over the run. So I'm going to rise first, and that goes up 1, and I'm going to run second, and that also goes over 1. So remember, slope is a fraction, 1 over 1, and we always simplify or reduce if we can. 1 over 1 simplifies to 1. So my slope, m equals 1. Is this last one proportional or a direct variation? Well, here's the origin. Does my line go through it? It starts a little bit above it. So this is not proportional. Okay, not direct variation. Alright, so that's how I tell from graphs. It has to go through the origin, and then I count the rise over the run. Okay. Tell whether x and y are proportional if it's direct variation, and then identify the slope. So with tables, it works a little differently. We are going to determine if it's proportional if the following happens. If I take the y and I divide by x, and it's the same for each of these columns of my table. So 0 divided by 0, 2 divided by 2, 4 divided by 4, 6 divided by 6, they all equal 1. So because they all equal 1, I can say that it is proportional, and my slope is equal to that 1. Alright, is this next one? So remember, I'm going to take y divided by x. So 1 over 4, 2 over 8, 3 over 12, and 4 over 16. Now they all look different, but if they all reduce to the same thing, then we're good. So 1 over 4, it can't be reduced. 2 over 8 can be reduced to 1 over 4. 3 over 12 can be reduced to 1 over 4. And 4 over 16 can be reduced to 1 over 4. So this is proportional. And the slope, or that's also known as m, equals 1 over 4. So in this case, they were both proportional. Tell whether, so now we're going to be looking at equations and deciding if they're proportional. So looking at these two equations, determine if there is direct variation or proportional, and identify the slope. So with equations, the simplest way is to make sure that the equation looks like the constant of proportionality. Remember that that equation looks like y equals mx. Notice I just have y equals and then a number being multiplied to x and nothing else. So if I were to look at these two examples and to find the one that matches that, that would be this one right here, where there's no extra anything like there is on this example. So this one's my proportional relationship or direct variation, and my m, remember your m is that number in front of x, or your slope. So my answer would be 4. Now is this one proportional? Well, this part fits, but I have this extra tagged on there. If I have any extra tagged on there, it's automatically not proportional. So what if I had the equation y equals 2x? That would be proportional. If I add or subtract anything, like minus 2, that automatically makes it not proportional. And I don't have to determine the slope. Alright, so let's try again with tables. 4 divided by 2 is, so remember, take y divided by x. 4 divided by 2 is 2. 8 divided by 4 is 2. 24 divided by 8 is 3. So does this have direct variation, or is it proportional? There's no direct variation, so I cannot write an equation, or I cannot come up with that equation. 1 divided by 2 is 1/2. 2.5 divided by 5, 1/2. 3 divided by 6 equals 1/2. And because each of these are the same, I would say direct variation. Now what do we mean by equation? Remember, our direct variation equation is y equals mx. And m represents this number that I've been getting. So my equation would say y equals 1/2 x. The cost y in dollars for x gigabytes of data on the internet plan is represented by the equation y equals 10x. Graph the equation. So I'm going to make a table, x and y. Notice my x goes 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, I think 4 points is enough to make a line. And we're going to use our equation. So it says y equals 10x. So to fill out this row, for an input of 0, if I put input 0, 10 times 0 equals 0. So I would put a 0 in this line. To plot that point, remember that's an ordered pair, 0, 0. If I plug in a 1, okay, if I plug in a 1 to fill out this row, I'm going to plug a 1 into x. 10 times 1 equals 10. So if I were to plot that ordered pair, I'd go over 1 and up to 10 and make a dot. Let's try that again. 10 times 2 equals 20, so 220. Make a point. 10 times 3 equals 30. 330. That's enough points to make a graph, connect the dots, and there's my graph.